Alright, let's determine the coordinates of the point on the graph of f of x is equal to the square root of 2x plus 1, where the tangent line is perpendicular to the line 3x plus y plus 4 is equal to 0. Okay, so we want to figure out where the tangent line is perpendicular to another line, and that other line here is 3x plus y plus 4 is equal to 0. This is basically standard form of a linear equation. We want to convert this into slope-intercept form of linear equation. So we're basically looking at y is equal to mx plus b. And you can notice here that if I just keep the y constant, I'm going to move the other terms to the other side. Y is equal to negative 3x minus 4. So the slope here is negative 3, right? So a slope that is perpendicular to this line, if this is negative 3 over 1, perpendicular to this is positive 1 over 3, right? Lines that are perpendicular to each other are negative, they have negative reciprocal slopes. Another line that's perpendicular to a particular line can be considered a normal to that line. Okay, so a tangent is one of the lines, so we're looking at the tangent is perpendicular to a normal, right? So the slope of the tangent should be a negative reciprocal of the slope of the normal. So the slope of the tangent here should be 1 over 3. Now, because the slope of the tangent is given as 1 over 3, we also understand that the slope of the tangent to any function is the derivative of that function f prime of x, which you can write as dy over dx, right? The rate of change of y with respect to the rate of change of x. And I find the first derivative of my function f of x is equal to square root of 2x plus 1. Now, if f of x is equal to square root 2x plus 1, you can rewrite this guy as 2x plus 1 to the power 1/2. And if I find the derivative of f of x, right, in this case, the derivative of 2x plus 1 to the power 1/2, you can notice here that we have to utilize chain rule. So first I'm going to do the power rule on the outside, 1/2 2x plus 1, 1/2 minus 1, right, which is basically negative 1/2, right, times the derivative of the inside, so d dx of 2x plus 1, and that's going to give us 1/2 2x plus 1 to the power negative 1/2, negative 2. And what I can do here to simplify this, I can multiply the 2 with the 1/2. Remember that multiplication is commutative, so we can reverse the order. So the 1/2 and the 2 cancel out, and you basically get 2x plus 1 to the power negative 1/2. The negative exponent, or sorry, the negative power would represent that we have a reciprocal, so this is 1 over the square root of 2x plus 1, right? Because the power of 1/2 is basically a square root. And we can understand that this is the slope of the tangent, but we also know that this is equal to 1/3. So if we compare the denominators, we can see that the square root of 2x plus 1 is equal to 3. So the square root of 2x plus 1 is equal to 3. So if you want to solve for x, I'm going to square this side. Whatever I do to this side, I'm going to do that to this side, to the other side, the right side. The square root and the square cancel out, so you get 2x plus 1 is equal to 9. If you want to solve for x, I'm going to move the 1 to the other side, so you get 2x is equal to 9 minus 1. Then 2x here is equal to 8. If you want to solve for x, I'm going to divide by 2. Whatever I do to one side, I'm going to do to the other. And you can notice here that therefore x is equal to 4. Now you want to figure out the coordinates of the point. So when you're looking at a point, you have to consider x and y. So we know what the x value is, we need to figure out the y value. But because we know what the x value is, we can understand that the point here is 4 and f of 4, okay, on the original function. So let's figure out what f of 4 is. F of 4 is basically the square root of 2 times 4 plus 1, which is the square root of 8 plus 1, which is the square root of 9, which is basically plus minus 3. Okay, so your 2 points here can be either 4 and positive 3, or 4 and negative 3. Okay, so therefore both of these points will actually have a tangent of 1/3, and that tangent is going to be perpendicular to the line 3x plus y plus 4 is equal to 0.